Okay, folks, sorry this one's a little late, um, but let's dive in. This is the review of the assignment part 2 of page 384, which began at number 35 through 42 all. It was due earlier today. Actually, it was due about 3 hours ago at noon today. All right, here we go. Number 35. If the sine of theta is negative 3/5 and the cosine of theta is 4/5, can we find any way to find the remaining functions? And the answer obviously is yes, we can. By the way, notice sine SOHCAHTOA, opposite over hypotenuse, cosine adjacent over hypotenuse. Does that suggest perhaps if both of the hypotenuses are 5 and the other sides are 3 and 4, does that suggest this must be the famous 3-4-5 ratio in right triangles? Could it be one of these? Yes. Does that help you? Maybe a little, but maybe not. Just an interesting observation. All right, now, having made that observation, we move on. Tangent. By the definition of tangent, or I should say the identity, the tangent identity that we see on page, I don't know, I've lost the page, says the tangent equals sine over cosine. You need to become a close friend of that identity. You're going to be needing that a lot. Well, anytime you see a tangent, first thing that should pop in your mind is, oh, sine over cosine. And I think through these exercises, we kind of get a good feel for that. Tangent is sine over cosine. So we simply put the sine, which is negative 3/5, over the cosine, which is 4/5. Then we remember our basic arithmetic, that division is equivalent to multiplication by the reciprocal 5/4. And that then, of course, gives us negative 3/4. It's over. Then the cotangent, remember the cotangent and tangent are reciprocals of each other. So the cotangent is simply the reciprocal of that, which is negative 4/3. Negative 4/3. Now the secant is the reciprocal of cosine, so secant must simply be kerchunk 5/4. And then cosecant is the reciprocal of sine, so it's nothing more than negative kerchunk 5/3. Negative 5/3. And I think I have the answers down here just to make sure we didn't do anything silly. Tangent, negative 4/3. Cotangent, or negative 3/4 rather, cotangent, negative 4/3. Secant is 5/4. And cosecant is negative 5/3. Everything is cool. And we move on to number 36. 36, same stuff. By the way, stick with me to the end of this video, even if you're saying to yourself, I've got this. Stick with me to the end, please. Sine over cosine, again, tangent, sine over cosine. So we just have 4/5 over cosine, which is negative 3/5. That becomes, of course, 4/5 times negative 5/3. Nice for the 5's to cancel. We're left with negative 4/3 for the tangent. Cotangent, think simple. Cotangent is just the reciprocal of tangent. By the way, that implies we could have another identity that the cotangent is going to be what? The reciprocal of tangent. Cotangent will be cosine over sine. Cool. All right, then that's cotangent. What about secant? Secant must be the reciprocal of cosine, so secant is just negative 5/3. And cosecant is the reciprocal of sine, so cosecant is 5/4. And there we have the final answers. Moving on to the next one, number 37. A little bit tougher because we're involving some radicals now. Tangent, again, is equal to what? Could it be sine over cosine? Yes, it could be. Tangent is sine over cosine, always has been, always will be. So we just take the sine and the cosine and make it a fraction, change the division into multiplication by the reciprocal. The 5's cancel, cool. The square root of 5's cancel, cool. We're left with nothing but 2. Very cool. Done. This is number 37, it's one of the odds, therefore for the rest of the answers, just see the back of the book, please. Save a little time there. Oops, did I miss one? 38. Okay, here are your answers for 38. Breezing through the rest of these because I think they're all so straightforward that you should be able to handle this. If you did not get these answers, then look back at the procedures that I've shown you on these others, and once you're comfortable with that, try number 38 again and see if you can get these answers. Number 39, please just see the answers in the back of the book. Yeah, you should have already done that. If you haven't already done that, then you are being negligent in your studies. As you work on assignments that include odd-numbered problems, you should be checking yourself as you go. Number 40, more of the same. Here are your answers. Ta-da, done. We move on. Number 41. The answers are in the back of the book. Yeah, I'm sure you've already checked that. So once again, move on. Stick with me here. Because one more time, number 42, I want to slow down a bit and look at this in a little more detail just as one last example. So, sine and cosine given to us. We know that tangent of theta is simply I almost said something wrong, is the sine of theta over the cosine of theta. So that means that the tangent of theta must be this 2 square root of 2 over 3 over negative 1/3. Of course that becomes 2 square root of 2 over 3 divided by, therefore multiplied by, the reciprocal of negative 3. Negative 3 over 1. And these cancel. We get negative 2 square root of 2. Don't forget that negative sign. Negative 2 square root of 2. That should be what I have here. Yep, negative 2 square root of 2. Then for the rest of them, it gets easier. For the rest of them, I would suggest, sometimes it's easier if you stick with this and do the reciprocal of that and simplify. In this case though, I don't know, it might be easier just to take our negative 2 square root of 2 and get the reciprocal of that. So cotangent of theta must be the reciprocal of, what was it? It was negative 2 square root of 2. 1 over negative 2 square root of 2. That's how you find the reciprocal of the cosine. I'm sorry, the reciprocal of the tangent. I never did write the answer here. Negative 2 square root of 2. So we just want the reciprocal of tangent. There's tangent. So I want the reciprocal of that. But then, of course, we haven't reviewed this yet today. Here we go. How do you get that radical out of the denominator? You multiply by square root of 2 over square root of 2. Numerator, square root of 2. Denominator, be careful here. What's square root of 2 times square root of 2? That's right. 2. 2 times negative 2 being negative 4. Now that's poor form. We don't like to leave that negative in the denominator. Sometimes we just leave negatives in the numerator. Sometimes we put it on the side. It's best to put it on the side. So we have square root of, a negative square root of 2 over 4 is the best form. This is very poor form, but it's technically correct. This is much better form. And that's cotangent. Then secant will be the reciprocal of cosine. Well, that's easy. The reciprocal of negative 1/3 is simply, how about negative 3? Remember, reciprocals don't change sign. If this is negative, the reciprocal is negative. So that means that secant, being the reciprocal of cosine, secant will be negative 3. And cosecant, and secant negative 3. Cosecant requires a little bit more work. Cosecant, let's get rid of this. Cosecant of theta is the reciprocal of sine, which means it is going to be 3 over 2 square root of 2, which is, well, let's just square root of 2 over square root of 2, which gives us 3 square root of 2 over, what do we do with this? Hey, same thing we did down there. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. We're done. 3 square root of 2 over 4. And there it is, 3 square root of 2 over 4. Okay? Okay, that's it. We're done. Oh, we're sort of done. A few last thoughts. There will be no new assignment since it is now well past 3 o'clock. I will not give you an assignment that's due the next day if I post it after 3 o'clock. Well, unless I give you adequate warning like I did, was it just yesterday? There will be no new assignment. We will not see any new material today. I will be offline on Monday, totally unavailable on Monday. The next new material will be on Tuesday. Since the next new material will be on Tuesday, that means the next assignment won't be due until Wednesday at noon. So in other words, you get the entire weekend off. You might want to spend a little time looking ahead somewhat in this section. Let's see, 384, maybe give you an idea of where we're headed next time. So you can look ahead, which would be really nice to do if you have time to do it. It's always helpful. We have just left off at the top of 378. No, we did some examples like example 3. We will be picking up at the very bottom of 378. And I wish we had time to do it now because it's really pretty cool stuff, but we're going to hold back. It's nothing but Pythagorean theorem. Bottom of 378, and will we finish the section next time? I suspect we will. Yes, I'm confident we'll be able to finish next time, and then we'll be moving on to the next section after that. So, what's this green arrow for? I don't remember what I have next here. Oh, yes. Anybody who dares to ask me what assignment is due on Monday or Tuesday will be inadvertently, I don't know if I spelled that right or not, they'll be inadvertently confessing that you're not watching the videos. Because right here, I told you very clearly, there is nothing due on Monday or Tuesday. There will be nothing due until Wednesday. There will be no new videos until Tuesday. No new videos, no new material until Tuesday, with an assignment due Wednesday. So if anyone asks me what the assignment is, well, I appreciate the confession. That will tell me what I need to cheer you out for. You need to be watching the videos. All right, and that's it. By the way, as I had to mention to one other person earlier today, whatever I say in the video will supersede anything that you might see in RenWeb or anything that you don't see in RenWeb, unless I send out an emailed retraction of something I said in a video, which I have had to do with my algebra class. But it's the emails and the videos that count. RenWeb may not always be up to date. I try. Yesterday I forgot to post something on RenWeb, and that's all right though. That's not what counts. What counts is what I say and what I email. Sometimes what I say has to be changed, and I send an email correction. All right, that'll always be clear. Watch your emails. And, of course, watch your videos. I'm done. You can shut me off now. Unless you want to see one last little thing here. How about this?